MongoDB. One of the first things that you'll need to do is download MongoDB. And you can find MongoDB at mongodb.org. Okay, and you can download for your particular operating system. So here's the latest version, the latest release, MongoDB 3.0, and it'll detect the operating system and will download. I mean, you can choose here the operating system for and your particular version. All right, Mac OS, Solaris, Windows. And you'll download and you'll install it, and it will create for you under program files. It'll create a directory under program files to install, and this bin directory. Inside that bin directory, you'll have a couple of executables that are of interest. So you should add the bin, this bin directory to your paths, right? So you can run the server from anywhere in the command line. So there are two particular executables that are of interest that we're going to cover today. One of them is the actual server, which is this one, MongoD. MongoD. Okay. The other one, Mongo, is a command line interface that allows you to interact with the database, right? So just like SQL or MySQL, you can, at the command line, you can do selects, inserts, and updates and whatnot. Same thing, Mongo. This command line interface allows you to interact with the database. Interactive. Yes, makes sense. By default, MongoDB will look for a directory called data in your root directory, right? And under data, it'll look for a DB directory under there. Okay, and this is where, again, by default, the server will store the data. Okay, that you're inserting or updating or removing. The data will go in here. Make sense? Everybody good? Although you can override that. You can tell MongoDB to instead use another directory, right? And it'll put the data there. But if you don't say anything, it'll store it here. Under data/db. Everybody okay? All right. So to get started with Mongo, at the command line, you can type in MongoD. MongoD. Remember, we put that bin directory in our path, right? So MongoD.exe is available. I can execute it from the command line, right? When I run it, it says it's going to start up, and it's listening. It tells you where it's storing the data. That's where it's storing it. And also it tells you that it's listening at port 270017. All right, so the server is running, and it's waiting for you to connect to it. All right, everybody okay? Yes? All right. I have another command line here. Is this it? Where I'm going to type Mongo. So Mongo is going to be it's a command line interface that allows me to interact with the database, and automatically connects to one of the schemas inside one of the databases in MongoD. And you'll notice that it's connected to test. Okay. You can tell that now that we're connected, we can ask. Can I make this bigger? Font 38. Color, screen, text. Okay. Okay. You can say show databases, and it says that we have an admin, course, F360, and local. So those are the databases that are there. And let's create one for this course. Okay. Let's do use CS 4550. Okay, so notice that it's switched to CS 4550. So that's pretty much similar to what we would do in other databases, right? Now what we could do is ask for like tables, or what tables are in here. All right, we don't call tables in MongoDB. We call them collections. Okay, so a database splits its data into tables, and tables have records. Yes. In MongoDB, instead, what we have are collections, and inside of a collections we have documents, right? but they're the analogous of tables and records. Okay, so if you can think about that, so we can ask for what collections are there, but there are no collections. Right? There are no collections. There are no tables. Right? And unlike relational databases, where you go through using several keywords to create a new table where you want to store data, over here it's a little less formal. Okay, it's a little less formal. If you want to store, maybe authors and articles, maybe you can use a command. All commands start with DB. If you want to be able to interact with a collection or a particular document, all the commands start with DB dot the collection that you would interact with. Right. So say I want to store a list of authors. Okay. So I would have a table or a collection called authors. Yes. Right. So there it is. So DB dot authors. That would be a table or a collection. And I want to insert data in there. Okay, I want to insert some data in there. Notice that there are no collections. Notice that I did show collections. There is no authors collection. I'm going to insert into this collection, this brand new collection that does not exist. I'm going to insert first name Alice and last name Wonderland. Okay. Nnotice that what I provide as an argument is a JSON object. You see that? The name value pairs, right? The property first name, and then the value, and then another property last name, and then the value Wonderland, right? Notice that it's inside of a curly bracket, so it takes as an argument a JSON object. Everybody okay? All right. If I do that, it says write result inserted one record. You see that? Inserted one record. If I ask for show collections again now, it says, yes, I do have one collection, right? I have the authors collection. I just inserted a record in there. Okay, so there is no formal way like we do in SQL relational databases where you create the table, you tell them what the fields are, and then each field you have to tell them what types there are, right? And then all sorts of constraints that these has to be unique, that has to be not null and things like that, right? Over here is much less formal. Okay, all right, we're going for simplicity here. All right, now that we have a collection, let's add another author in there. So let's create and put do Bob and then Marley. The way I went to the previous line, I just pressed the up button, up arrow, and it goes back to the previous line. So I can retype something. So there it is. So I inserted another one. I inserted two. One more. Okay, everybody good? If I show the collections, I still just have the authors collection. Everybody good? Now, if I want to see what the records are in there, we don't call them records. We call them documents. Over here, what I inserted, I didn't insert a record. I inserted a document. Okay. We can now say db.authors, right? If I want to list, or what I would do in SQL database, I would do a select star, right, from authors. The equivalent of doing that is that you use the find method, right? So if I type that, notice that 3 records come back, right? Again, we don't call them records, we call them documents. Notice that it has the data that we put in there, right? First name Alice, last name Wonderland, first name Bob, last name Marlon. So the same data we inserted just a second ago, right? Plus, notice that it added a field of its own. See that? That underscore ID, right? Fields that start with an underscore are typically managed fields. Fields are unmanaged by the framework. Fields are unmanaged by the database, right? What it's doing is that it's creating on its own, right? It's creating its own primary key, right? A key that uniquely identifies this document. Everybody okay? Right? Notice that this might be a little hard to read. So as part of the find, right, I could add other things. Right? I could say find pretty. Right? This is going to do the same thing, but it's going to format it so that it's a little bit easier to read. right? So if I do that, notice that this is maybe a little easier to read, right? So each record it's in its own line, each field is in its own line, so it's a little easier to read. Everybody okay? Right? So yeah, so find allows me to do that. I can retrieve a particular record. You know, if I can, you know, just like in select statements, I can have a where clause, right? I can say, you know, select star from authors where, right, first name equal whatever, right? I can do that in SQL databases. Same thing here. I can do that. I can provide a parameter. I can provide a clause or a predicate, right, that says that, you know, for instance, I want first name, right, to be equal to Alice. Okay, and the predicate is as a JSON object. Okay, so I can say first name Alice. If I do that, it returns a single element. See that? It only returned Alice. See that? Okay. Or if I just want Bob, it returns just Bob. Everybody good? Okay. Or if I know the ID, I can also query by ID. I can say by ID, so I can say field ID, right, is equal to, but it has to be this. It can't just be the value. It can't just be the value of this ID. It has to be the entire thing, because this is an object, right? So I'm just going to copy that, and I'm going to paste it. Right? So I do that, it returns that one record. Everybody good? Okay. So let me retrieve all of them. Right. Notice that we have Alice Wonderland, Bob Marley, Charlie Garcia. Right, and say we insert one more. Insert. We insert Jerry Garcia. Okay. If we do a find, and now we have two people that are called Garcia, right? If I do a find, db.find, right? And I db authors.find, and I say where last name is equal to Garcia, you would expect that two records come back, right? Indeed, yes, those two records come back. You see that? Make sense? Everybody okay? All right. All right. So let me find all of them again. So there's three. Let's insert another one, right? Let's insert yet another one. But this time, I forgot that the field was called first name. I inadvertently forgot that it was called first name, so I just call it first. Okay. And in here, I'm going to say Charlie, Jerry, Dan, Ackroyd. Now, typically, this would not be allowed in relational databases, right? Whether you have, a field, called something different than all the other fields and all the other records, that makes no sense, right? But before our relational databases would stop us because our schemas were very well defined. Yes, were defined by the creation of a table, right? In that table, you had to explicitly tell me the names of the fields and the data types. Over here, we didn't go through that, right? There is no equivalent here, right? If I insert, it's okay, right? I inserted. If I do a find, notice that I have some records have first name, last name. This one has first and last name. You see that? It doesn't have first name, right? Okay. So these records are very loosely typed. Okay. There's no validation whether this is of the correct data type, if it's an integer, if it's a whatnot, right? Those things have to happen early on, right? At the application level, through several plugins that we'll be using shortly. I can keep adding things. I can keep adding another one. Right. This one has first, last, and this is Ed Norton. Right. And age. Right. And then I don't know Ed Norton's age. Anybody? No. All right. I'll say he's 40, but he's not. He's much older, right? So notice that I have Ed Norton has actually 3 fields. See that? Whereas all the other ones have 2 fields, right? And if we do a find, right, notice that I have here Dan Aykroyd having first and last name, whereas Ed Norton has first, last, right, and it has an age, whereas the other ones don't have an age. You see that? Okay, so it's very, very loosely typed. Okay, very much like JavaScript. Isn't JavaScript loosely typed? Right? Okay. All right, so we know how to insert, we know how to find things. How about update and delete? Well, let's see. We can remove Dan Aykroyd over here. We can say authors, right? Remove, and we can give it an ID, or we can give it a predicate, right? If I just say remove and I'm saying anything, it'll remove all of them, right? Yep. So for instance, if I give it a predicate and I say where first matches Dan, right, it says that 1 was removed, right? If I do a find again, notice that Dan is no longer there. See that? And not only I can remove by first, last, by ID, yes? Okay, by any particular field. I also can update. I can do db dot authors dot update. I can say update. If I update, I need to tell which one do I want to update. If I don't tell it the predicate, it's going to update all of them, right? Just like in SQL. Although you can turn that off. You can say whether you want all of them or just one, or the first one to be updated. We can say that I want to update. First, I need to give it a filter and say which record do you want to update. Okay, so I'm going to say the one that matches where the field first is equal to Ed. Okay, so that's the predicate, right? So the first argument to update is a predicate. Okay, so the one that matches whose first name is Ed, and what do I want to do? This is what I want to do. Okay, I can do set. I can do increment, right? If I have numbers, I can decrement. I can do all sorts of things. So all these commands on what I want to do with the record that matches are commands. These commands are all MongoDB commands, and they all start with $. Okay. So for instance, I want to set. Right. I want to set, and then the argument to set is another JSON object. Right. And here I can tell it what fields and the values. Fields, value, fields, value. Right. So for instance, I can say I want to change the first name. I want to change it to Edward. Edward. Okay. And I know he's not 40, so I'll make his age a little bit older. I'll say 41. Okay. You see that? All right. So I'm gonna update. It says matched 1. Okay, so if I do a find, notice that Ed has been changed to Edward and the age has been changed to 41. Everybody good? All right, so let's see. We can find all of them. We can find by ID. We can find 1. We know how to create. We know how to update, and we know how to delete. Those are the only 5 basic commands that we'll ever need, right? We call them the CRUD operations, right? I always call them the CRUD plus 1 because the read is really 2 reads, right? Read all and then read by a particular predicate. Yes, usually find by ID. Yes? Everybody good? Okay. All right. One other thing here is that I'm going to insert another. I'm going to insert another one, right? I'm going to insert. And this one, let's see. We have Edward Norton. Let's insert one more, Frank. Last name, Herbert, right? And maybe he's the author of books, right? Of several books. Now, the way you would, say you want to model the fact that you have authors and the authors have authored many books. Yes, correct. And typically in relational databases, the way you would do that is one of 2 ways, right? You would either have a table of authors and you have a table of books, correct? And usually there's a one-to-many relationship there, right? One author has written many books, correct? And the way you would model that, one way to model that is that the book would have a reference back to its parent. Yes, and that's called a foreign key, right? Books have a foreign key back to their parent record. Yes, and so if you have Frank Herbert, you have many books that Frank Herbert wrote. You would have all the books that Frank Herbert wrote is stored in the books table, all of them having foreign keys back to the Frank Herbert record. Yes, that's how you typically do it. Another way to do it is if you have a many-to-many, right, where many authors might have written many books together, right? So you might have, if one book has many authors, then you can't, if it has many authors, well, then the book can't really store all the authors. What you instead do is that you have an intermediate table that says which books were written by which authors, right? That's another way. You have a mapping table. Let me draw this for you. So the classical way of doing this in relational databases is to do the following, right? You would have two ways. Either this is author and this is books, right? And the diagram is like this. You have one, you have many. And the way to implement this is that the author has a primary key, which is the equivalent of our underscore ID, yes? And then you have the book referring to that primary key with a foreign key, right? And an instance of this is that in the table authors, you would have many records for each author, yes? So this is a record for A1, A2, A3, A4. So you have 4 authors. Each one has a primary key, maybe 1, 2, 3, 4, yes? And then you have a books table here, and you have many books, right? And here's book 1. So this is book 1, book 2, book 3, book 4, book 5, right? Each one having a foreign key that says who wrote this book, right? So that book was written by, if it has a foreign key 1, 1, these two were written by this author, yes? If this has 2, 2, 2, these 3 books were written by that author. Everybody okay? All right, that's relational databases 101, okay? Another way to do this, notice that this would not allow me to capture the fact that you could have co-authors, right? Maybe a book was written by 2, 3, 4 authors, yes, right? So this does not allow me to capture that, correct? Right? The way you would capture it is that one way to capture it is that instead you would have, basically what you want is this, right? You want to have many to many. One author wrote many books, right? We have that already. We can do that here. But one book was written by many authors. You can capture that, right? Right. This doesn't allow us to do that. This cannot be implemented. This type of relationship cannot be implemented in relational databases. So what we usually do is we put an intermediate table here. An intermediate table that this is author to books mapping, right? That says that author wrote that book, correct? This is a classical many-to-many. The way this is implemented is as follows. You have here table author, right? A1, A2, A3, A4, A5, right? And here you have the intermediate table saying that you have 2 foreign keys. You have a foreign key. This is the author foreign key, and this is the book foreign key. And you say, if you want to say that, and here you don't have a foreign key. And this is this also has a primary key, 1, 2, 3, 4, 5. If you want to say that this book was written by author 1 and 3, you would say book 1, right, was written by author 1, and book 1 was written by author 3. So 2 records. It says that, right, this relates to the first book, and these relates to that author and that author. It says that that book was written by these 2 authors. Yes? Correct? Or if you want to say that, also you want to say that author 1 also wrote book 5. So author 1 wrote book 5, right? All by himself, right? With no one else. Hey, everybody okay? Right? Now, NoSQL databases can implement any of these ways of representing data. Okay? In SQL databases, what you do is to recuperate the data, right? If you ask me, who wrote what, right? If you want to do a select statement, you have to join all these 3 tables, right? You have to join them. You have to do something like, select star from A, B, and A, B, right? Where, A dot primary key is equal to A, B dot A foreign key, and B primary key is equal to A, B dot A, B foreign key, right? You join it. This is the join. Joining. This will return all the records, right? For which authors match with which books. Okay, so these joins go away. We don't have those in relational database. In NoSQL. Okay, there are other ways. There are other things that are available to us, right? Like maps and map reduce and things like that that will iterate over your data, right? Instead of asking the database to scan, right? We scan it, right? We provide the actual query exactly how is that we're going to extract the data. Right? I'm not going to get into too much into databases, but let me show you. Okay, what we typically try to do instead, if a book is something that only lives as part of an author, okay? If a book is strictly part of an author, right? Instead of having it as a separate table, it's a separate document. Instead, what we do, we can store it as an array. Yeah, we can store it as an array, right? So we can have here title, book 1. So that's one book. Let me get another book in here. Title, book 2. Okay, I've inserted Frank Herbert. And if I do a find pretty, notice that I have that Frank Herbert wrote these 2 books B1 and B2. You see that? Right? The problem with this is that if I ever need the books all by themselves, say I want all the books, right, regardless of who wrote them, right? That would be a problem, right? Because I would have to iterate over all the authors, right, and then ask them all the books and then aggregate all that, right? Then that would be an issue, right? But if you can strictly assume that the data only lives as an embedded piece of data of someone else, right? This is totally fine, right? What this does is that it eliminates the need for joins. There is no need for a join, right? The data is embedded in there. You see that? Okay. There is no, let me go to the book table and let me go to the author table. Let me join them, right? And then find the ones that match, and then I'll give you the ones that match. No, the data is already there. You see that? Okay. And this way of organizing the data is encouraged, right? Using NoSQL databases. All right, over joins. Okay, but again, if you do need the books to live all by themselves, right, then that's okay. You can have a separate collection of books, right, and you can still have ways of organizing it that other way, right? Here's another way that we can organize it. Okay, for instance, say I create a collection of books, okay, and I can say, let's see, I can say db.books.insert, right, and I want to insert a book called Title Dune, right? So that's one. right? And if I doing, I don't know, it's been a while, huh? Retics of Doom. Anybody read them? I forget what the titles are. I can do. I can find all the books. I can say db.books.find. So these are all the books. There they are, right? We have 2 books, right? If I want to say that Frank Herbert wrote these books, okay, what we could do is we can say db.authors dot update where the I can say update where the first name is Frank, right? And what I want to do is I want to set a brand new field called book IDs, BIDs, book IDs, okay? And that's going to be an array, and the array is going to be the IDs of the books. Okay, there's yet another way that it can be almost like foreign keys, but not really, right? I'm going to copy this ID, right? So that's one ID, and the other one is this other one, right? Uh-oh. Ah! Where'd it go? Oh, there it is. Okay. All right, so I'm going to close that. Close that. What else do I have? Let's see. Close the parentheses. Okay, I think that worked. Let me do a db.find authors. .find and pretty. Okay. Notice that I have 2 ways that I've represented it, right? This is called the sub document representation, right? Where a document, where this title, right, is the title of a book, right? It's an instance of a book, is embedded as an array, right? As an element of an array that is part of a larger object, right? This one is book IDs. This is almost like foreign keys, but unlike the way you have this in relational databases, where you have one to many, right? In relational databases, you have author and you have books. How does this work? The book has a foreign key back to the parent, no? It is a child who has a foreign key back to the parent, correct? Right? Over here, instead, it is the parent who has an array of indices back to the children. See that? It is the parent who knows who their children are. You see that? Okay. I can have it both ways. I can have the book. I can have the book know who their authors are. I can say db dot. Let me see, db. I have authors there, right? I can say db dot books dot update. I'm going to update this book, right? I can say where ID is equal to object ID that close, and I want to set close that. Okay, I want to set so that it knows who its authors are, right? So this could be author IDs, right? So this could be an array, right, of, say, it was written by, say, this guy, right, and was written by some other guy. Okay. There we go. So now if I look at the books, oops. Notice that this book over here, Dune, knows that its authors are. You see that? So not only do I have, the parents know who their children are, but their children could know who their parent who their parents are. You see that? So now, something that could not be done in relational databases where you can have many-to-many like this, star, star, that was impossible to do that in relational databases, right? You had to have a mapping table in between, right? Over here, you could do it, right? The parent has a collection of references to the children. The children has a collection of references to their parent, right? No need to reify. If you looked at if you went to 3200, I don't know if you went to that topic of reifying, right? That to be able to implement this, you needed to put an in-between table, right? So yeah, so there's many ways of representing it, representing data, and you know, it's up to you how you want to decide to represent the data, right? It should be the driving force behind how you're going to represent the data. The driving force should be, you know, what do you want to, what data do you want to have in the clients, right? What data do you want to, how you want to manipulate the data, right? Be able to insert and remove and whatnot, right? Who's going to be the parent? Who's going to be arrays of what? Okay, and then just represent it that way. Okay, represent it that way. Imagine that you have these objects. You're going to manipulate them in memory, and then you're just going to put them back, right? Okay. All right, so that's MongoDB. Again, a crash course on MongoDB. There's plenty more to say, but what we're going to do is that we're not going to interact with MongoDB at the command line, right? That's pretty boring. Instead, what we want to be able to do is interact with it programmatically, right, from Node.js, right? So that Node.js, when it gets a request to to create a new item from the UI, it will actually insert something in the database. Yes? Okay. All right. So let's go back and let's create something here. Okay, so I'm going to create here a directory, and this is MongoDB1. Okay, let's go in here, and let me open that up with this. I'm going to open website. I'm going to go to C and MongoDB1. There we go. We'll open that. All right, so we have it open. So let's create a first server here. Let's create a server. Let's say add JavaScript. Okay, so we're going to do the server.js, and so first of all, let's play around with MongoDB. See if we can connect to MongoDB from the server. Yes. Okay. To do that, we're going to be using a library that is very popular today for connecting to MongoDB from Node.js. Okay, there are a lot of libraries. There are lots and lots of libraries, but one of the more popular ones is Mongoose. Mongoose.js, not the bike. Okay. So locally, we're going to have to install Mongoose. Let's see. We're going to go cd MongoDB. Okay, we have the server there. We're going to install Mongoose. To install Mongoose, we're going to say npm install Mongoose. Okay, that's going to download the libraries, right? It's going to create a directory called node modules, right? I'm going to put in there the Mongoose library. See if I can make this a little bigger. There we go. Oop. Okay, we install that. If we do ls, we have node modules. If I do ls node modules, notice that we have Mongoose installed. Yes? Okay. All right. Now that it's installed, we can go to the documentation, right, at the home page of Mongoose, and we can just copy this. Let's copy that. And let's go to our server, and let's paste that. So the way this works is that, very much like we were using Express last week. Yes, we're going to use the require function to be able to load or make available the libraries so that they're available at the server. Yes, we were requiring Express last week. This time we're requiring Mongoose. Once we have Mongoose, we can use several methods inside of that object that allows us to, for instance, connect to a database. Okay, and you have to provide what it's called a connection string, and that connection string gives the IP. It starts off with MongoDB, the server where this is running, or the IP address. Right, if this is running at a particular IP address, then you would need to provide that IP. Right now, it's running at localhost, meaning local to our machine, and then the database that you want to connect to. Okay? In our case, it's CS4550. Right, that's the database that we want to connect to. Once is there, what we need to do is create a schema. Okay. What Mongoose tries to do is, up to this point, we saw that we were using MongoDB, and it was allowing us to insert anything. It was allowing us to add new fields, right? It was allowing us to do all sorts of things. It was kind of like anarchy, right? It was allowing us to do anything we wanted, right? Which is great. The database can be very easily manipulated, and it can be very easily extended. But we want some normalcy, right? Something that we want to wrap something so that it abstracts this and gives a little more form. Okay, so Mongoose allows you to do that. So people that come from relational databases, they're going to feel a little more comfortable if they interact with MongoDB through Mongoose. Okay, so for instance, one of the things we can create here, let's create a website schema. Yeah, you can create schemas. So for instance, you can say that Mongoose, this is let's say new Mongoose schema, right? And then you can provide the fields and the data types for those fields, right? Very much like we would expect in a normal database, right? In a regular database, you provide fields and their data types, right? That's how you would create a table. So a schema is the equivalent of a table, right? The equivalent of a table. Again, it's an abstraction, right? Really down below, it's just going to be stored in collections, right? But it will we're going to be interacting not directly to MongoDB, but through these schemas, right? So for instance, if we inadvertently type fields that are not part of the schema, Mongoose is going to stop us. Not MongoDB. MongoDB would be fine with it, right? But because we're going through this API, the API, saves us from our own mistakes. Okay, so if we mistype a field or we give the wrong data type, right? This API will stop us, right? And we'll make sure that we do things right. Okay. So a website, we're going to create a brand new website. What field? What might we want? Maybe the name of the website, right, is of type string. Okay. Maybe it has a URL, also of type string. Maybe the date it was created, right? So of type date. Okay. Right. Now not only can I give it types, right, a type of that particular field, I can also give it default values. So for instance, what would be a default values for when it was created? Created. It would be like a timestamp, right? The day that the website was created. Yes, we would like to know the current time when this record was created. Yes, right. So what we could do, instead of just giving the data type, we could give it an object instead. We'll give it an object where that says that the type is date and the default is date.now. Okay, we could give it a default value. All these can do this, right? We can say, instead of just giving the data type, we can give it an object that says type, string, and then the default is HTTP CNN.com. Okay, make sense? Right? Or it's just, if you don't give it a data type, if you don't give it a default, it'll default to the default of the data type. Okay, so for instance, it will be empty string for name. Everybody okay? Everybody good? All right, so let's see. Once we have the schema, we would like to be able to instantiate one of these records and then just save it. Right, so let's do that. We're going to say var website model. What we do here is we're going to say Mongoose. Oops. Mongoose.model. And we're going to create a model from it. The model is the one who's going to allow us to interact with the actual database, right? So we're going to say model. The name is going to be website. Oh wait, did I misspell it? I'm sorry, no. Website. Okay. And we give it the schema. It creates a model from that schema. Now that we have that schema, we can instantiate, we can create new instances of websites. So for instance, I can say var website 1 new website, right? And I can give it as argument all the various parameters, all the various values that it's expecting. It's expecting a name, right? I can give it a name. You can say website 1, the URL. I'm not going to give it the other ones. Well, actually, I am. I'm going to say URL www.website1.com. And I'm not going to give it the date. Once I have the instance, right, I can save it. I can say website1.save. Website1.save. That is going to go to the database and actually do the insert of that object into the collection in the database, right? Before we do that, let's look at the database. Right before we do that, we're going to say show collections. We have authors and books. We don't have websites. Yes, we do not have the websites collection, and we are using this database, this schema. If we run this, and we say node server.js. Notice that I did show collections before there was no websites, but now there is. You see websites, right? That save, right, inserted that object into the database. Right? If we do db.websites.find pretty, notice that it inserted the ID from it's the same ID that we were using earlier. Here's the name. There it is. Name website 1. That's the website name that we gave it. Yes, right. Also notice the URL. That's the URL we gave it. You see that, right? And a default value for the date. The date is an ISO date, 2015-3. It's May 3rd, right? And it's 17. Why 17? T17. That's what, 5:52. I think my server has got the wrong time. Wait, it should be this time. It should be 12:57. Interesting. All right. Anyway, so notice that it created that. You see that? Everybody good? Right. We created that. Let's create a couple more. So so let's create another one. Website 2. And just name it website. Just website. Let's run it again. And let's find there they are, two websites. Everybody okay? Everybody good? All right. So yeah, so now we have a code that can interact with the database, right, and insert records into that database. All right. Now that we've created a couple of instances, okay, I'm going to comment this out. I don't want to create any more websites. What I want to be able to do is see if I can retrieve them from the database. Okay. To do that, we can say we can use the model website and use the more or less the same functions we could do. We can use when we are interacting with this in the interactive command line, right? We can say find website.find will return all the websites. Okay, and the way it gives them back to us is by calling a function that we give it as an argument, right? Whatever function we want to give it. The function has to have the following signature. It has to receive as first argument an optional error. If anything goes wrong in the database connection or something fails, it will notify us by passing us an error. And the second argument of that function contains the actual data that comes from the database, right? So we'll say docs for documents, the documents that are coming back from the database, right? And what we're going to do is we're just going to print them out to the standard output. Okay, we're going to say console.log.docs. Okay, so we're going to run our Node server. We're going to run it again. And there they are. Comes back as an array. You see that? It's an array. Why? Because there are two records in there. You see that, right? Two records, and it comes back. The first one is website 1. There it is, website 1 and website 2. Okay. Right. Not only can I find all of them, I can find by some. So this is called find all, right? This is find all, right? I can find by a particular predicate. I can say find, right? And I can give it a predicate, maybe name, where the name is website 1, right? So it's gonna match. Well, it could match several documents, right? We know that's gonna match only one, correct? Right? So this is find by name, if you will, right? Find by name. Let's run that. So the first one, the first array is from the first query that returns all of them, right? The find all. The second one is also an array, but it only has one element. It has the element that matched my criteria, website 1. You see that? Right? It returned just one, but it's still an array, right? Because it could have been more than one document, correct? Right? If I know that it's going to match only one, right? And I want to find it by ID, I can say website.find by ID, and I can provide the ID. I can provide. If it's by ID, then the understanding is that these are all primary keys. So the value you're going to give me presumably is a value that you've taken from the ID, from an ID, a real ID, and it matches a single document, right? So it's not going to return an array. It's going to return just one document, presumably, yes? So let's give it an ID of a record that exists. So let's see this one over here. Let's give it this ID. Right? So I'm going to pass it. Notice I don't have to wrap it in the object ID that I had to do in the Mongo command line. Right? I can just pass a string. Right? It understands that it's going to try and it'll instantiate as an instance of object ID, and then filter by underscore ID. So notice that over here we were giving a kind of like fields and then the value for that field. Over here, because it's find by ID, the only thing that I can expect here is something that represents an ID, and this returns function again, same thing, error. Presumably it's just one document that will be coming back, and we can do console doc. So we run that again. All right, that last one, notice this last one. Notice that it's not an array. See that? It just returned just one single instance. You see that? Everybody okay? Right. All right, so we know how to insert into a database. We know how to find all. We know how to find by a predicate, right? The other two is what? Updates and deletes. So let's do a delete Yeah, let's do a delete. Let's do a delete. So let's say we want to delete, let's say I want to delete website 1, right? So I'm going to select that ID, right? What I can do is say that, let's say website dot remove, right? And remove accepts as argument the predicate by which you want me to remove things, right? What is it that you want me to remove? Oh, I want you to remove the thing, excuse me, that match an ID that has this value. Okay, and oh wait, that is equal. There we go. Okay, and it's going to remove it. It's going to remove it. Once it removes it, we're going to do a find all again. We'll go find all again to see that indeed that has been removed. So we're going to first remove and then going to find all to see that it's no longer there. Yes. So let's do that. Let me see here. Let's do a find all here. Okay, we have two records. This is from the command from the interactive command line. Here we're going to run. Okay. And looks like it did not work. We still have it. What's going on here? Blah, blah, blah. Remove website dot remove. Here's the ID. Remove. Why don't you like? Do I need to put it in? Need to put it in a. Are you expecting a function here? Here. Try again. Okay, I think it worked now. Yeah. Okay. One of the things that I was expecting is it was expecting the second argument, right? Where it notifies us that it has succeeded, right? One of the parameters that it passes us, the response that it passes us is, for instance, how many records were affected, right? So the data that it passes us is how many records matched. All right. So we know how to remove. The only last thing is can we update? So let's do that. Let's update. We're going to do website. The update. We're going to update the last remaining record. We're going to update this record. Okay, we're going to update that record, and we're going to say we're going to update where ID is equal to, right? Oops. Wait. Okay. Actually, no. Let's do it this other way. I'm gonna find by ID. I have the ID. Oops. Have the ID. Now that I have it, I can do function. Here is the error and the document, the actual document. Now that I have it, I can manipulate that object that's coming back to me, the document. For instance, I can set the name. I can change the name. So I can say doc that came back. That's the doc. Let me print it first. Make sure that it's that one, right? Console.log the doc. This is I'm going to say console.log find by ID. Let me run that and just make sure that that's the one. There it is. Find by ID came back with this one. Find by ID we did. Okay, it's this one. Wait, what's this over here? Why is it twice? Why did it do twice? Find by ID doc. There's only one, right? Wait, find by ID. Why did it? Okay, it's this one. What's that one? Oh, you know why? Okay, so what's happening is that all these calls are asynchronous. Okay, meaning they go off to the server and they don't wait for the server to come back. The execution just continues, right? The server, when the server comes back saying, yes, I was able to update or delete or whatever, right, will come back to us saying, yes, I was able to, to delete it. Here are the results. Yes. So because these are asynchronous, the order in which things occur is not guaranteed. Okay, so you have to be careful, right? These are not serialized. They're not synchronous. They are asynchronous. So, for instance, this one probably is from a previous query above. So what I'm going to do, I'm just going to comment all those out and just leave that one. Okay, there it is. So find by ID returns just one object. There it is. So I want to change it. Let me change it. I'm going to change the name. So the current name is what? The current name is website 2. I'm going to modify the document just like it was a normal JSON document. I'm going to change the name to be website 222. Right? And the way we're going to put it back and update it, right, is by calling doc.save, right? That's going to synchronize the instance that is in RAM, is going to write it out back to the database. Okay, so let's do that. Stop that and run it. Okay, I'm going to go back here and I'm going to print the content. There it is. The website name has been changed. You see that? Everybody good? Everybody still with me? All right. All right. So now that we know how to do create, update, delete, we know how to do read one, read many. Let's build something. All right. Let's build something. Let's see. Let's create several websites. Let's create several websites. Comments. Okay. Let's create website 1. And I don't want to do this. I don't want to do this. I want to just create several websites. So we're going to put website 1 back in there. And we're going to save. I want to create several of these. So there's 1. Let's create website 1. Let's create website 2. Oh, no, I have website 2, right? So let's do 3, 4, 5. And we're going to write them all. 1, 3, 4, and 5. So 1, 3, 4, and 5. I'm going to save them all and run it. Okay, let's let's see. We have website 222, 1, 4, 3, 5. There they are. Okay, so we have several websites in there, right? Everybody good? Okay. So one of the things I'd like to be able to do is from the client, from Angular, I would like to ask, hey, give me a list of the websites. Yes? And I would like to have the websites that are in the database, right? So what I'd like to be able to do is something like Express. Oh, we don't have Express. So let's install Express. Let's go to Express. So Express.js. And we're here, get the guide, the API reference. So we're gonna need, let's see, we need this, right? We need that. I'm gonna copy it here. We're gonna put it right before Mongoose. And then we're gonna have here something listening, right? So we're gonna go at the bottom. And we're gonna be listening, and we're gonna listen, say something like API/website. right? So that one, what should we return? What should we return there? We should return all the websites, right? From the database. That's what we should return, correct? For now, we're just going to say hello. So let's see. We already created this. I'm gonna comment this out. I'm gonna comment out the creation of all these websites. Right, I'm gonna leave it there so that they're still there for when I push it to the source control, so you can still see it. Let me see if Express is working. Let me start it. Oops. Oh, we don't have Express. We need to install that. So we do npm. Where are we? Wait a minute. Okay, so npm install Express. Okay, there we go. We have that. So let's run now our server. Okay. If we go to our local host, we say localhost 3000. What happened? Not get 3000. Why not? What is it? It's listening at 3000. Oh, because it has this URL. There it is. Hello world. Okay, so Express is working. So what do we want to do? We want to go back. We want to go in the server and say, hey, query all the websites, right? We know how to do that. Where is it? Where is it? Fine. There it is, right? This one knows how to query all these guys, right? I'm just going to replace this. Right? This is going to return. We're going to find all the websites. Here are these are all the websites. We want to send it back to the client. We're just going to say response.json docs. This is data that is coming from the server. We're just proxying it back. We're sending it over to whoever's asking for it, right? So let's stop. Let's run it again. Now let's refresh. There they are. These are the websites that we created earlier, 222, 1, 4, 3, and 5, right? This is data that is in our database. This is our data. You see that? Right? Isn't that cool? Right? What about being able to ask for a particular website, right? So for instance, I would like to be able to have the same thing, but if I give you an ID, if additionally I give you an ID for that website, I want you to find by ID, right? And as argument is, I want to parse the ID from the URL. That's in the request parameters, right? ID, there it is. I'm going to pass you that, and you're going to return a single document, not many documents. And I'm just going to send it back to you. Yes? Right? So let me stop that. Oops, I didn't mean to do that. UCS 4550. db.websites.find. Yeah, okay. Let me stop the server. There it is. Let me restart the server. So, okay, so this keeps working. If I want an individual ID, like maybe this one, right? If I can copy the ID, I can provide it as an argument, right? And it returns just that one document. Yes? See that? Right? Okay. How about creating or deleting or things like that? Well, right, for creation, we're gonna need to be able to post, right? For deletes, we're gonna have to be able to use deletes. For now, let's create a little UI, right? A little Angular that displays all this content, right? So let's stop the server, and we're gonna go back to Express, and we're gonna create a public directory where we can put our little a little application, service application, right? So there it is. So we're going to have a public directory. Let's open up a public directory. Create a public directory, add directory, public. And in there, what do I want in there? Let's see. I want from my downloads, in Bootstrap. I want to copy all these 3 things into public. Plus, we want Angular. So we have Angular and route. We're going to copy that. Angular. I think that's it. Right? Let's keep it simple. We're going to need refresh this and create a small index page. So this is index.html. And in here, we're going to load Bootstrap. So this is href CSS bootstrap.css rel style sheet. Here we go. And this is script. I'm just going to load Angular. That's all we're going to use, right? So we're going to say script source equal JS Angular. That's it. And then my application, my app. And this app is going to be called websites app. Okay. And it's going to have a single div with a single controller, ng controller, websites controller. Okay. And just to make sure this is working, I'm just going to have the controller say hello. So let's create a little application in here. Add JavaScript. I'll call it app.js. Create a module here. App is going to be equal to Angular module new app. Not going to depend on anything. And then create the controller app.controller. Controller is just going to be a function that receives scope. And it's just going to say hello for now. Let's see if it says hello. So it's going to say scope hello equal controller hello from. Okay. Let's see if this works. Let me restart the server. And let me try and hit it. There we go. Hello from website controller, right? So we have a minimal Angular application, right? So the first thing that the Angular application might want to do is go fetch those websites. Yes, because I want to display that on my user interface. So we're going to need the HTTP service, right? Let me inject that $HTTP. And we're not going to need that anymore. So we're going to say $HTTP, go fetch using get those URLs we just used 2 seconds ago, API website. That returns all the websites, right? And in the success, as a response. And we're going to say that we're going to send that to the UI. We're going to say that these are the websites, and the UI is just going to render them. Okay, let's see. There we go. All right, we got an array. Right. So this is an array. This is data that's coming straight from the database, right? Correct. Right, which is pretty cool. So we can just iterate over this using a table, maybe. So table. Class table striped, maybe a table. Let's say T body, and then T row. So ng repeat website in websites, and then td. I'm going to just say the name, right? So this is going to be website name. Okay. What else? So does that render? Okay, there we go. And if we want to remove it, we're going to add an additional TD here. It's going to be button class button danger. And I'm just going to put in a I'm going to put a times, which is an X. There we go. And I'm going to send it to the right-hand side. So this is going to be whole right. There we go. All right. So when I click on this, I want to delete it, right? So I'm going to say ng click. Click equals delete. And I'm going to pass it the ID of what I want to remove. Yes? Right? Where's the ID is part of the website object, right? So I'm going to put it underscore ID. Right? So that's the ID that came to me from the server. I'm passing it back to the controller so that the controller can then go back and tell the service that I want to remove it, right? So yeah, so let's go back to my app. I'm going to make an event handler for that delete. Wait, did I call it delete? No, I'm going to say remove. Okay, delete is a reserved word in JavaScript. So I'm going to say here $scope dot remove, which is going to receive the ID. And we're just going to do an alert for that ID just to verify that it's connected. So if I click on this, notice that that's the ID. See that? Right? So these are all the IDs of what I want to remove. Okay? Very good. Now that I have the ID, I can go back to the server and ask the server to remove it by saying http.delete. This is what we did last week, right? Delete. We're going to say we're going to API. We're removing a website. And we're providing the ID, right? And hopefully it's going to come back in the response. It'll come back with the remaining websites, right? Oops. We're going to do console.log response. All right, so this delete doesn't exist in the server, so we're going to have to build it, right? So we only have something that is listening for what? Let's see. It's only listening for the gets, right? It's getting all of them, and getting one. We want that response to a delete. Here we go. With a delete URL, API website /ID, right? So here we have function request response. Right? And what we want to be able to do is find that website. We want to find that website and remove it. Or we can say we can do website.remove and pass as argument the ID. Right? We can say remove where the ID is equal to the request.params.id. Right? Okay. What we would like to be able to do is, once we have removed it, we would like to respond back with the resulting websites, right? One way to do it is to just do this again, right? This one that retrieves all of them. This retrieves all of them, right, from the database, correct? Yes? So you might be tempted to do this, right? And that would be wrong. Well, actually, it might work half the time. Sometimes it would work, sometimes it wouldn't. And the reason is that remove is asynchronous. Okay? It could be that it sent out the order to remove, and by the time it got to the find method, that record has not been removed just yet. Okay? So when it runs the find, it retrieves all the records, even the one that was about to be removed, right? Because the command of removal has not yet made it, perhaps, right? So this is kind of like a race condition. We don't know which one's going to go first, okay? Again, because it's asynchronous, it's not synchronous, right? Even though they're written synchronously, they execute asynchronously, right? So there's two ways to synchronize this, to make this a synchronized call as opposed to an asynchronous call. One way is to use promises, right? And I would have to start covering promises. I don't want to cover promises just yet. In promises, this is a nice model that allows you to serialize, right, things that would normally be unserialized, right? That would be asynchronous, right? One naive way of doing it, which is very easy, right, is the fact that we know that this remove has a callback. You remember, right? There's a callback telling you, hey, I'm done. I'm done removing, right? So by the time this inner function gets called, the record is no longer there, right? So we're guaranteed that that record is no longer there now, right? Now that it's not there, we can do the find all, right? Now, okay, now retrieve all of them, right, and send it back to the client. Make sense? Right? This nesting is usually considered bad practice, but it's a quick and dirty way of implementing it. Next week we'll look at promises and how to do it with using the Q a plugin that allows you to do promises, right? All right, so there we go. So we could delete. Oh, we're almost out of time. Just one more. Let me test this to see if this works. Let's run that and let's refresh this. Let's remove this. And it didn't work. Oh, it did remove it. Huh. Okay, let me remove that. Why is it not refreshing? Interesting. Oh, I know why. I know why. Let's remove the alert, and this should be scope.websites equal the response. There it is. Refresh. There we go. Okay, now I remove, and the UI is synchronized. All right, let's leave it here, and let's wrap this up on Thursday, okay? Thank you.